Hey guys, May 3rd, 2020, come at you with a video. I just want to, first before we get into this, I really want to say a thank you to everybody. I was very humbled by what you guys have done for Scott so far. I am going to leave this PayPal link in my description here. Go watch my previous video if you want to know what's going on. It explains it. But I can't tell you how thankful I am, and most definitely thankful Scott is. It's helping him so much, and at least in his mind, that it's just, yeah, it's awesome. It just reaffirms my thought that there are more good than bad people in this world, and that proves it. Okay, that kind of stuff proves it. So thank you so much. And we'll go ahead and dive into the information here, guys. Okay, guys, start you at the Schumann. Now, you know I've been talking about this 10 o'clock UTC, right? Right here. The start times of these spikes. Now, this is from like a week and a half ago, back on the 18th through the 20th of April. Now, you can see how they kind of mirror each other. So, I think these were two separate spikes, but, you know, right next to each other. So, that's what this one looked like, and I've already talked about that one, right? Well, the 10 o'clock thing is back, okay, number one, okay? And I want you to understand that the shape that this thing is taking is very similar to the other ones that start at 10. So I don't know. I'm going to go back and count how many signatures popped off at 10 UTC for like the past month or two. And I just got to go back and look at them and count them. I'm just curious. But then this is the one you would see today. Okay, if you went over there right now. Again, the 10 UTC. But I've also discovered something, just if nothing else, just for myself. We oftentimes call this thing the heartbeat of Earth, right? We're talking about frequency, and when we talk about ourselves, we have to understand that, right? So let me show you a different tool that I come across. This is one of them. I found a couple of them. Now, you're looking at this. It's very highly pixelated, you know. Doesn't look too impressive as far as quality or whatever. But then we got this one. Okay, I come across this one. And then this one looks very much similar, right? Now, I'm going to go ahead and apologize for what I just did. Okay. The reason I did that is because I wanted you guys to understand how I looked at this when I first seen it, and kind of, you know, it kind of clicked. The light bulb went off, right? This says heart energy. And we call the Schumann the heartbeat of the Earth, right? I always thought that that was figurative at best, right? Is this something this is just a term we use to describe the frequency of our planet? Well, I think we may be quite literally looking at the Earth's heartbeat in a very literal sense. That you know, if people have put this together before, I haven't seen them put it together this way. And the only reason why I say this is because this is like helping me understand this at a higher level, at a bigger. I got more understanding of what I'm looking at. So that's why I showed it to you guys this way. So check this out. This is a normal heartbeat, right? It's from an EKG machine. All these I just showed you are from EKG machines. Okay? Or heart monitoring machines, looking at the frequency of our heart. Okay? So, we look at that, and then, you know, I take you over here to this one 2 days ago, and we're looking at that. Well, I flipped it over. And look at that. What's that look like? It looks just like that. So, you know, if we take our baseline right here, obviously we got some lower frequency here popping down. And then, you know, we got the spikes up here on the top. So if we look at this, what does that look like? Our base frequency is 7.83, and it's kind of like right here on this graph, roughly. Okay? So we're seeing a really similar looking spike to this. So are we quite literally looking at the Earth's heartbeat? You know, I don't know why I haven't put this together in my head before. It just hit me while I was doing my video. I made a video earlier today, and I screwed it up, so I had to remake it tonight. And I'm kind of glad I did, because I didn't really realize this until, I don't know, half hour before I started making this video. So let me know what you guys think about that. I mean, is that really what we're literally looking at, the Earth's heartbeat, when we look at this? That most certainly, man, I don't know what to say. And somebody else has shown you guys that before. I apologize, but I had never seen anybody talk about this before, like in this way, and show you a visual like this, because, you know, I really want everybody to have the understanding that I just, kind of the epiphany in my light bulb went off, and I was like, wow, look at that. So, we'll go ahead and move on. Okay, guys, I got you over here at seeds, and there's a couple things on here I want to discuss with you. Okay, we're looking at this, and this is our view. Okay, the satellite's right in front of the Earth, looking at the sun. So let me fast forward this a little bit, and what I want you to look at is this at first. Okay, now this is something we typically see on like the SETI website. For those of you who don't know what that is, you can go over and look at that tool if you want. It is called SETI. You can go over there and look at it all you want and mess around with all the different models they have. I would encourage you to do that. I used to show people how to navigate that, and I'm going to make a playlist to show people how to do that again. But for this video, I need to show you this because it would be such a long video if I went into a huge explanation on what's going on with that. But if you see this, okay, now as we go forward, see how it's growing? Now, most people, they look at that, including myself, until I realized what this was. It was like, wow, man, what is that? It almost looks like a comet tail, right? And something's moving to the right, maybe. And before we can move on, though, do you see this right here? That's probably a small meteorite, or even a big one if it's closer to the sun. It showed up. That's most definitely something there. I don't think that that's a charged particle or anything messing with the camera, because it doesn't look like it. It has a clear, like, I don't know, popcorn-looking tail to it. Okay? But that's what we're looking at on that. But right here is what I want you guys to understand. Okay? Look at and concentrate on right now. So I'm going to fast forward this a little bit more. And we get to this point right there. Okay, then you see another one happen, right? What this is, guys, it's a planet. I'm not sure if it's Venus or Mercury. I have to go look at the star chart. I'm not sure yet. But it's a planet, and it's giving off light, whether it's reflected light from the sun. But it's at that perfect spot at the edge of the camera's view, okay? And we see this a lot on HI1, like I said before. And it looks like something's going to explode and everything else over there. That's not what it is. It's just it's a light source that's bright enough at the right angle that causes this camera to interpret the data wrong. Okay? So if I move forward some more, we can keep going with this. And again, so let me, I'm just going to slow it down and start it up as a time lapse here. Okay? Now watch over there where I showed you guys, okay? Right in here. You'll see it start coming out. It's right there. See, that's the planet. Alright, I haven't looked to see what planet it is yet, but I want you guys to see that part of it. So let me, I'm going to stop this here in just a second because I've seen a CME happen. And I'm going to show it to you here in just a second. You see it popping off right there? Okay? Now, most of us would be like, oh my gosh, it's coming right at that planet. We can't really say that, okay? And the reason being is we don't really know. We'd have to go look at the star charts to begin with. But this black occulter, the sun's surface is right there. The occulter's there, so that means that when this, I'll tell you what, let's use this side because it's actually bright over here. It's better, right? Anyway, when this actually gets behind this occulter, we don't know if it's between the occulter and the sun, or if it's actually going behind the sun. So we don't know unless we go look at the star chart. So don't assume when this thing goes behind this occulter that it's actually, going behind the sun. It could actually be going in front of the sun between us and it. Okay? And I hope you guys understood that. But there was a CME right here happening at the end of the day. Okay? Like just a few minutes ago. So that's what's going on with that. And, and something else I want to say here too. You're seeing a lot of, like, debris floating around. Because we're seeing a lot of these little streaks. Okay? What's going on, guys? We're actually passing through the debris of Halley's comet. Okay? There's a couple other people have talked about us being in that meteor shower right now. So what's happening is the satellite's in a position that these meteorites and stuff are flying by. And also something I want to say here real quick before we move on. That bigger asteroid that missed us the other day, it had a smaller one that was kind of traveling with it. And they didn't, number one, they didn't really tell us about it. But it came within 22,000 miles of blasting one of our GPS satellites. You know, and they knew about it before. So you got to ask yourself, were they uncertain whether or not that thing was actually going to make it and hit us? It came close enough that it was going to take out a satellite. When we're talking about 22,000 miles, guys, we are talking about just like a hairline in miss in cosmic measurements. Okay, you take in consideration the whole space, right? 22,000 miles is not that far. I mean, man. So were they uncertain what it was going to do? And that's why they didn't mention it till after the fact? They said that they knew it was here before it got here. But they waited till after it had passed to tell us that it barely missed one of our GPS satellites. Crazy, man. You know? Anyway, back to this. Sorry about that little side rant there. But you're seeing a bunch of debris. So we're going through that meteor shower that we go through quite often, actually. And it's from when Halley's comet came through. It drug a bunch of space debris with it. Okay? Now, you know, we're looking at this, and I know what everybody's thinking. Okay? Because I was thinking kind of the same thing. It looks like it's pointing directly at this planet. You know, Mercury is always orbiting the sun. If this is Mercury, I don't know that it is. Okay? I'd have to go look. But if it is, Mercury doesn't typically instigate CMEs. Okay, it is still like 27 or 33 million miles away from the sun. So we got to keep that in mind. And it's always there. So if Mercury was causing this CME, it would be causing it a lot more times than what we just see it here. Not to say that something can't happen between the sun and Mercury and cause something. That's not what I'm saying. I'm just saying that the odds of this of Mercury or whatever planet this is causing this CME are probably pretty low. That's what I would say. And again, guys, you can see over here on the red how much debris we got going on. But yeah, so that CME continues. And I'll take you guys over to SDO and show it to you here in a minute. Okay? Now, you know, the next question is it coming at us? You know, I don't know yet. I'm going to have to go research that out. You're seeing it for the first time just like I am. Literally, this happened a couple hours ago. But that most certainly looks like a decent-sized CME. Okay? Okay, so we're over here at Stereo A. Okay? Now, our view from this one is from the side. So, Earth would be here. Well, let's do it like this. Earth would be kind of right here. The satellite's here. And it's always looking at the sun. So, when stuff is popping off the right side from Stereo A, it could possibly be coming at us, is what I'm saying. And this confirms that this is actually moving this direction. Okay? It does look like it's coming off the front side. Now, whether or not they're going to consider this a complete CME yet, this is just happening, so I don't expect any of the tools to really be updated as of yet. By tomorrow morning, we should be seeing something. But I know it's kind of hard to see on this red one and even the other one. But you can, Stereo A is so highly pixelated that it's hard to point stuff out. But I look at this thing all the time and I can see it. Not sure if you guys can. But you can see right at the end of the time lapse, if you watch right here, it starts to get bright. And we'll watch it do it right here. You see it happen right there? I know it's hard to see. I apologize for that, guys, but not much I can do. But it most certainly is putting off some energy on that, you know, there it went. You see that? I know it's hard to see. I probably shouldn't even be showing it to you because it's really, you'd have to go over and look at it for yourself. Okay, guys, I got you at SDO. That most certainly is a CME. Okay? This is the 171 angstrom. Here's the sun. And it actually looks like the sun may be reacting on the other side at the same time. Right here. Okay, we're not seeing much. That might not have been able to escape the sun. But this one over here most certainly did. See how it shoot off like that? We'll zoom in here and let you see it again. Right there. Okay. It looks to be coming maybe from that sunspot, the old sunspot that had rotated off. Most certainly could. Now, judging by this, it does look like it might be coming at an angle. So we may take a sideways blow from this. I'm not sure yet. We can actually, we may take a right on the chin. Don't know yet. But you can see how when these things blow off, if you watch it, you can see the main one go here, but we also had it kind of split like that. See that? So the actual center of where that happened would be in between those two. So it's kind of like right here, if you can imagine. Now watch what it does. See how it kind of just puffs out like that? So, you know, it's probably being influenced by, again, this sunspot that's rotating off right now. At best, it's an active area on the sun. So, wanted to show that to you because it most certainly is something we should look at. Now, I don't think this energy probably didn't leave the sun yet because it looks like it's curling back towards. And we see that with the filaments a lot. They'll go out there quite a ways off of the surface of the sun and then kind of curl back in. Now, we also got this new little area right here we're going to keep our eyes on. Okay, because it seems as though it might be catching some energy here. And, you know, we just need to pay attention to it. It looks like it might even be doing some small flaring. Don't know yet. But again, as this thing becomes, you know, here's the equator. Earth is here. When this thing is like right in front of us, it'd be the best time that it could actually influence us as far as a solar flare or a CME coming at us. Now, I have to say that the sun is most definitely becoming more active, guys. I really truly think that we're heading into the new sun cycle right now. There's so many, you know, signs here on the sun. Now, it doesn't mean that we're going to go from 0 to 100, okay, in like 2 seconds. That's not what I'm saying. I can see activity increasing. That's kind of what I'm saying here. Typically, it's kind of a slow thing, but there's no rule that says it can't, you know, really get active pretty quick. Now, within a year or two, we would most definitely expect to see a lot more activity, okay? Because as we're moving back into a solar maximum, you know, we're going to see more activity. All right, guys, this is over at spaceweather.com. They do a good job over here, I think. And what this is this is the orbit of Halley's comet and the debris that's with it. Okay? So what we're going to do, we're going to zoom in a little bit here, and we're going to take a look at this thing. Let's go back over here. Now, if you guys go over here and look at this, you'll be able to take your finger and move it back and forth like this. So if we want to go on our orbital plane, this is what we would do. Okay, we would stop it. You know, it's hard to do a little bit. Maybe I can zoom out. Okay, that does help a little bit. But you can see how it's on a slanted elliptical orbit there. Okay. And this is what comets typically do. You see how they're going out, but when they actually come and they get whipped around the sun. And then back out into space. And like, you know, we were talking about Comet Atlas and Comet Swan and all that kind of thing. That's exactly what they would do too. But, you know, Atlas burn up pretty much. Pieces of it may or may not make it to the sun. Don't know yet. But that is what's going on with that. So if we want to know where Earth is at, obviously you see our inner solar system here. Okay, Mercury would be purple. Venus would be the orange orbit, and then Earth would be the light blue, and obviously the red would be Mars. Okay, so if we're looking at this and we want to go like see what plane it's going on, we can see where the Earth is at the time of this, which would be right there. Okay, or on the other side, but I think it's over here on the bottom. It seems as though we pass this debris field twice a year. I'm not sure if that's correct or not, but it looks like it could. So let's look at this right here from this angle. Yeah, probably not. It looks like we might just pass through it the first, I don't know. because of its elliptical orbit here, guys, and I know this is kind of a strange way to look at it, it just gives us a different point of view. So as we rotate through, I don't know, I'd have to research that and see if we pass through it twice. We could, I don't know. Okay guys, I got you over at NOAA, space weather. Now this is the X-ray flux I've been talking about, and we're going to see that slowly increase, probably its base level anyway. You can see it's starting to take an uptick again. It kind of dove off after those sunspots rotated off from in front of us. But it looks as though maybe that small one that I just showed you guys might be bringing it back up a little bit. We'll watch it for flares. You'll see spikes like that if it starts flaring. But we'll see. Geomagnetic activity. It's really calm right here, guys. Not a whole lot going on in that aspect, which is good. I mean, it's not a bad thing or a good thing. It just is what it is. So that, okay. Now we're going to look at the ACE data real quick, I guess. You can see where stuff started acting again. Here's the solar wind stream. The speed is in yellow. You can see how it kind of bumped down and then it started raising back up. And then the density, which is actually, in my opinion, almost more important than the solar wind speed itself. I've been saying that for probably over a year now. Because that's something I noticed. I observed things that the solar wind speed would be slow, but the density would be high. So we would still have significant impacts on our magnetic field. You know, we don't have to have the speed there for that to happen. If it's very highly dense material, it will most certainly give us a jolt. Okay. And also, guys, I'm going to do this real quick. I hope you guys just give me some time here real quick. I'm going to show you this. I've mentioned this before, but here's the sun. We'll call this the Earth, right? And here's connectivity between the two. Magnetic connectivity, right? We're always connected to the sun via the interplanetary magnetic field lines. Okay, there's bunches of them, right? So when these charged particles leave the sun, okay, we talk about solar wind. That's what it is, okay? But it's not wind on how we actually think of it here on the planet. It has nothing to do with that. What's going on here, this connection, those particles follow that line of connection. That's how they get here. Okay, if it's a highly, let's say it's a low dense set of charged particles, solar wind coming at us. They spiral down these lines of connectivity, and that would be like a low dense one like that. Okay, now if it was high dense, it would be more like this. Okay, so when it gets here, it gives us more of a punch. That's kind of what I'm saying. We don't have that big, long, lower dense that's actually going out a little bit further from center. Okay, so the higher dense material is actually more compact, and that makes perfect sense. But it's been thought that it took high solar wind to really give us the good smacks. But now they even did some papers last year, studies and stuff that they've done, and they're saying, hey, the density really affects it really rough. So I wanted to bring that up. Now here's the Enlil model. Again, they changed it already from yesterday when I think I showed it to you guys yesterday or the day before. I can't remember. I don't trust this thing more than 2 days out. So as far as I would trust it would be about this level. Because right now we're sitting right here. And just yesterday when I looked at this thing, there was a big spike here. That's gone now. So I don't know what happened. Now with this CME I just showed you guys, this could change again. So kind of keep that in mind. We'll cruise down through here real quick. There's the aurora forecast here on the left. But you can see here's the other graphs and stuff, the models that we typically look at. This is the same data I just showed you on some of the other models. Okay guys, this is the CME tracker. That CME I just showed you guys has not shown up on this yet. Okay, here's the timestamp. And it's showing you a CME that happened back on the 29th. The one that we were talking about already. It wasn't going to hit us and it didn't. It may have gave us a slight little bump. Not sure. Doesn't really look like it did. And why I'm saying that is this is a top-down view. If you look at this thing blow off the sun right there, you can see where it really does not really affect us. The Earth is that yellow ball right there. Now this is the side view. Okay, gives us a different view there. And then again, guys, this is our orbital path that is stretched out into a straight line, just to give us another point of view, give us some kind of depth perception by using all three of those angles. Okay, because this is a two-dimensional model trying to represent something that's three-dimensional. So we'll keep an eye out for this thing to update. It very well could be by morning. Don't know yet. Okay, guys, this is the global earthquake map, and this is just from the past few days. And I know a lot of people had already reported on this, so I didn't really feel the need to like jump out there and try to give people some of this stuff. But we did have some significant earthquakes. If we scroll down through in here, we got the one that happened out in the Mediterranean. Let's scroll in some more. Hit that other one. Okay, it says 4.2. My settings must be all jacked up here, guys. That was a 6.6. Okay, one of those. I don't have my settings set right on USGS right here, but there was a 6.6 in that location. It didn't really. I'm not sure if it did anything. I don't really think it affected anybody a whole lot there. But there also was one over here in Puerto Rico that was a 5.7, I believe. It did some damage. Okay. But I just wanted to point that out. You guys can go look just about anywhere else and get information on that. A lot of people reported on that. But I did want to just at least mention it. Okay, guys, I think I am going to end it here. We'll keep an eye on what's going on with all this stuff that I just showed you guys. I know there's a lot of stuff for you guys to take in tonight. But I hadn't done one in a couple days. And but anyway, the main thing here, guys, on what I'm showing you right here is the fact that don't freak out on that thing that pops up right there. Inevitably, somebody's going to be out there saying that that's something that it's not. But I wanted to head that off at the pass and at least give somebody some other information here to look at. But we're also looking at that CME. Okay, we'll wait for the CME tracker to update to really get to see if it's actually going to come at us or not. It looks to be like it could be coming, at an angle, which is in towards us at an angle. That doesn't mean it's going to hit us, but it doesn't look like it is going to miss us either. We may take a glancing blow from that. But that was that definitely was a CME. You can even see it over here on the red one, which sometimes they're hard to see over here. But if we watch that, you'll see discoloration, kind of a blur happen. Sometimes it'll get bright. But it happens right about there. See it? Okay. So that most definitely, we're going to have to watch that one because it looks like it could be pretty sizable. As far as, I ain't saying it's a full halo looking thing. No, that's not what I'm saying. But it looks like this could be a rather strong one. So we'll keep an eye on it and see what happens. And so we'll go ahead and end the video there. But that Schumann thing, guys, that was kind of crazy for me. I hadn't really put that together in my brain like that before. And if somebody else has already done that for you guys, well, I guess you got to see it again, I guess. But I'm not sure if they have. Hopefully that, helped somebody out there understand a little bit more about that Schumann resonance that we talk about a lot and how important it actually is. So are we really quite literally looking at the Earth's heartbeat when we look at that graph? Because it most definitely looks like an EKG machine to me. So anyway, guys. God bless. Yeshua saves, and you can drink this Kool-Aid.